Hi, it's me, Dr. Prasad Puthiyillam, on my YouTube channel, My Intuition, offering regular as well as entrance coaching classes on chemistry as well as learning mathematics. This is class number 6 of basic concepts of chemistry, balancing a chemical reaction, stoichiometry and stoichiometry calculations, and limiting reagent. Balancing a chemical reaction. According to the law of conservation of mass, a balanced chemical equation has the same number of atoms on each element on both sides of the equation. So usually trial and error methods are used to balance a chemical reaction. We'll take an example. For example, combustion of propane C3H8. Okay, here the reactants are C3H8 and oxygen gives the products carbon dioxide and steam. Okay, so balancing the number of carbon atoms. So we can go for two methods. Either we can start balancing carbon or balancing hydrogen. Whereas balancing oxygen, it is difficult initially because left side only one oxygen is there, right side two sides are there. So oxygen here on carbon dioxide as well as on steam. So best way is to either to balance carbon or start with the hydrogen. So we'll start with carbon. So carbon here on reagent side, see three carbon atoms are there, whereas on the product side only one carbon atom is there. So that we can give a number three to that carbon dioxide. So 3 moles of CO2. Okay, can give a number 3 here. So carbon is balanced. Now we can go for balancing hydrogen. So hydrogen here on right side, that is in the product side, steam, 2 hydrogen is there, whereas in the reactant side in the propane 8 hydrogens are there. Therefore giving a number 4 on steam, it becomes 8 hydrogen. Therefore you can balance the number of hydrogen as by giving 4. Now the remaining is oxygen. Now here on the product side, carbon dioxide, 3 carbon dioxide, therefore it is total 6 oxygen, and 4 on steam, therefore 6 plus 4, 10 oxygen is there on the right hand side or the product side, whereas on the reactant side only 2 is there, therefore we can give a number 5 becomes 10. Therefore balancing the number of oxygen atom becomes 5. Therefore C3H8 plus 5O2 gives 3CO2 plus 4H2O. It is a balanced chemical reaction. So balanced chemical reactions are important in terms of stoichiometry. Stoichiometry is a word which is derived from Greek, means stoichion means element and metron means measure. That means it is a measure of element. So stoichiometry thus deals with the calculation of masses or sometimes volumes of the reactants and the products involved in a chemical reaction. So let us consider the combustion of methane. The balanced equation for that combustion of methane is CH4 gas plus 2 oxygen gaseous state, carbon dioxide gaseous state plus 2 steam gaseous state. So here bracket it is given G represents that they are in the reactants as well as products. They are very, all elements are in gaseous state. If you write S, it represents solid state. If you write L, small letter L, it represents the liquid state. Okay, so here all are in gaseous state, therefore given G. Okay, so here the CH4, it is only one, it is written, it is not written one, but it is understood that it is one CH4 plus 2 O2, 1 CO2 and 2 H2O. Therefore, the coefficient 2 for oxygen and steam and 1 each for CH4 and CO2 are called stoichiometric coefficient, as well as you can use that number to represent the number of molecules, number of moles, volume or weight, etc. can also be represented. Say example, this from this equation, the balanced equation, we can say that 1 mole of CH4 gas reacts with 2 moles of oxygen gas to give 1 mole of carbon dioxide gas and 2 moles of H2O, that is steam. Okay, that is in terms of mole. In terms of molecule, 1 molecule of CH4 reacts with 2 molecules of oxygen to give 1 molecule of CO2 and 2 molecules of steam. Okay, in terms of volume or say liter, 1 liter of methane gas reacts with 2 liters of oxygen to give 1 liter of carbon dioxide and 2 liters of steam. Or if you calculate in terms of molar mass of CH4 is 16, that is 1 carbon 12 plus 4 into 1, it becomes 16. 2 molecules of oxygen, it becomes 64. CO2, that is 44, and 2H2O becomes 36. So we can say 16 gram of CH4 combines with 64 grams of oxygen to give 44 gram of carbon dioxide and 36 gram of steam. So these are the different methods we can use to express a chemical reaction. Once we know to express the stoichiometry, once if we have a balanced chemical reaction. Limiting reagent, say if 70 grams of oxygen is supplied, we already know the equation represented one. Okay, if 70 gram of oxygen is supplied to react with the 16 gram of methane, the product form will be only 44 grams of carbon dioxide and 36 gram of steam only. That means a excess of 6 gram of oxygen was supplied for the reaction, whereas only the 16 gram of methane which decides the amount of product formed, that is 44 gram of carbon dioxide, 36 gram of H2O. That means once the 16 gram of methane it is consumed, the reaction will stop. Therefore methane, it is the one which limits the reaction, or we can say it is the limiting reagent. So thank you very much for watching my video. Please do subscribe my YouTube channel. Once again, thank you very much. Have a nice day.